Hello, ladies and gentlemen, boys and girls. My name is Octoman, and today I'm talking about editor scripting. Editor scripting is here for helping us in creating, for example, things we need to have to create repeatedly. For example, we can create levels and level designs based on particular input or particular rules we're gonna set in editor scripting, so we can actually um, get into editor scripting without any what would I wanted to say? Well, we can make use of editor scripting for our levels to design them, or maybe to randomize things. We can create complete worlds just with editor scripting. So we basically press one button, and when we are pressing that button, the world is going to become generated for us based on the rules we have set so far. That's what we're going to talk today, or what we want to about today. I'm gonna use some. Editor scripting for creating a Bomberman level today. So at first I need to find my items, my assets I want to use here. So these are just some textures. I want to prepare something pretty quick. So at first we're gonna have a folder for our textures. That's where all my textures are going to be in just a second. Textures, and I'm gonna drag in like 4 textures, which are going to be for my walls, my bricks. Like the destructibles are going to be brick type, and the other ones are going to be, well, not brick type. The other ones are going to be like outer walls and probably also the floor, like the plane. Okay, so usually you're gonna create a level by creating for a Bomberman game with maybe using a plane. This is going to be the ground plane, and then you're creating materials and design them, and also put the textures like a 111 tiling on these. So I'm gonna make use of these textures for this. So first gonna go in pretty quickly, create another folder for materials and create a new one. Where is material? There we go. So this is going to be maybe brick, and I can also duplicate that by Control D, and I can rename this one with pressing on F2, and maybe this is going to be, let's say, metal wall or something. Doesn't really matter. So in here in the albedo, I want to have like this metal thing, and on the normal map, I'm gonna put my normal map. So this is just the material for all the wall pieces, and also I'm gonna have some for the bricks. So just a diffuse for the bricks and a normal map for the bricks as well. So it's looking like it is like stamped in or whatever. So it looks a bit into that. So what you now would do usually is to design a level for a Bomberman game or for any other game. You're gonna take everything from the ground and start to manipulate that. For example, okay, I'm gonna put this material, this metal wall, onto my plane, and then I go to the material and say, oh, I have to set the tiling now. And since I know that this plane starts with a 10 by 10 size, I'm gonna go and, well, not in offset, but in X and Y, I'm gonna set this one by hand so that everything is tiled correctly over the size and the material. But let's assume you're gonna create another size. Another level, then you need to set the scale like by hand. Okay, I want to have it a big bit bigger with like 15 in scale, or in this case maybe 1.5 or 1.2. What is happening now is the scale is completely off, so you need to go into the material again and see what's the scale right now, and so on and so forth. So editor scripting is later on going to take care of that sizes. So for now, we just take care of, oh, I need to mark them as that materials in a second as normal maps. So this one here needs to be marked as normal map as well as this one. So To do all of that, we can make use of editor scripting just to automatically resize and refit the tiling of the planes and all the other stuff. So what we need to do is we need to at first create a brick. I'm gonna create some cubes for that. I'm gonna put this to 0, 0, 0 at the very beginning, lift it a bit by 0.5 in the Y. And what I want to do is I don't want to have this like so that we are not seeing the bottom anymore. I want to have this more like it is scaled a bit down, maybe like 0.8 or something, so we can see or have like a gap in between this positions later on. Oops, not 8, 0.8, please. And 0.8 here as well, so we don't lift it by 0.5, but 0.4, I guess. Yeah, looks good. Okay, so now, if you are going to go and create your levels again, what would you do? You would go and just copy and paste this cube. Let me put some material on it. You would, oh no, it's a wrong material. We want to start with the outer wall. What you can see now, we have the problem, for example, that we need to resize that. So we actually create, maybe we duplicate this material pretty quick and make this one cube metal or something. And whoops, typos, metal. And I need to go down with the tiling here again. So I have a 1 by 1. And of course, I want to make sure that I drag this onto my cube. So now I have all of these on my cube. And they're looking okay, but if you go to if you want to design like your complete level now here, you need to duplicate that, bring this to the next point, duplicate that, bring that to the next point, and it's taking just too much time in case of level design, because at first you need to create the outer walls, then you need to create the inner parts. Like on the usual Bomberman, it is like every 4 tile or every 2 tiles like this away from here to and from here to, you're going to have an undestructible wall. What you need to do is you need to even put this over here, and now you need to fill like the complete play field with that. And now you see, oh no, I made a mistake. I made the mistake that the next wall over here is not matching because we couldn't pass through that as we do on the other side. What do we need to do? We need to resize the plane first, and we need to put the material together and all the other stuff. And this is just too horrible in case of level design, right? Because you forgot this or that and so on and so forth. Editor scripting will help us to automate all of that stuff. So let's create everything we need for that. At first, we need a script folder, of course, to keep everything organized as usual. Just call it scripts. By the way, this is going to be a rather intermediate tutorial already, so just keep that in mind. I name it create level. Basically, this is not going to create the level. Oh, I need to rename that after the compiler is done. Otherwise, I confuse myself probably later on. There might be an error in a sec, but we take care of that in just a second. Okay, so I open this script up in MonoDevelop, or if you like to, you can also work in Visual Studio. And I zoom in a bit, and I need to rename it here as well. This class needs to be create level. Save that. And what we just define here is everything we're gonna need or make use of for our level or for our editor script. So we don't do any functions. We don't put any functions in here. We can, but actually there are some troublesome areas where we want to, or which we want to avoid. Okay, so at first we need to know where do we want to start to create our level from. So we can say public vector 3. You can also use any game objects to define that if you like that. We need a start vector where we start to create our actual game field from. Or I need that. I mean, you can try to go around with that. Then I need an offset. This offset represents, well, usually the offset between 2 tiles. And I also want to make my life easier and implement some header here. So a header is nothing else than showing us a bold text in the editor itself or in the inspector itself, where we can define, okay, these are going to be prefabs which are actually coming next. So next one is going to be, we need a game object. Actually, our prefab of the game object type wall. Then we have public game object. I name it inner wall. It is going to be basically the same prefab, but I want to make use of it still to show you better what's going on. Then I'm gonna have another game object, which is going to be a destructible wall, basically a destructible wall. And in the very end, we're gonna have the ground plane we were talking about already. Public. Make sure everything is public so we can drag stuff in. And it's going to be our ground plane. All of these will be used later on or manipulated based on whatever we need later on as well. So I take another header over here because I want to have some placeholders which are going to take care of where do we want to parent things to. So in this case, I name it placeholder. So we have later on a placeholder for all outer walls. We have placeholders for inner walls as well as for destructible walls. So for example, if we do any mistake, we can easily go into that placeholders, delete whatever has to be deleted, as well as keeping the hierarchy clean. So public transform outer wall holder or something. Outer wall holder. I need to put this into parentheses. Otherwise, it keeps staying red. Basically, I can also copy this one over here. This is going to be our inner wall holder. I'm not sure how far we come today. Probably I split this section into two. And we're going to have like a destructibles. So destructibles holder. Okay, these are going to be just empty game objects we're going to create in a second or minute. And then we're gonna have a grid size. I'm gonna give myself another header over here just to make sure that I give myself also some information. And in this case, I want to say set grid size to be bigger than 5. This is going to be important later on. We're going to talk about that in a bit. Why that is the case. Why is this is the minimum. Okay, speaking of that, we're going to now put in some values for our grid size. So we have an int grid size x. You can also make use of a vector if you like to, vector 2. And we're going to have another public int grid size y, or in this particular case, it's the z-axis because we don't go in height. We just go forward and sidewards. We can also randomize things later on. Probably we want to keep that for the moment. And also we can, also we can create some layers later on for particular things. So we can already put something like destructibles in a specific destructible layer mask if we like to. But, oh, well, I don't know if we're going to make use of it for now. But you can do that. So we're gonna put in layer mask here as just a header, and we give it a public layer mask. It's going to be the layer mask. Pretty cool. So nothing fancy about that. So basically we are done with that script. We don't need to do anything or need to put in anything in here, except we need to put this somewhere onto our empty game object, which is taking care of all that stuff. So what we want to do is, of course, we want to rename that. So this is our create level game object. Just rename that. And now we take the create level function on that and we are good to go. So now we can put in all the information we want at the moment. Okay, so what we need now is we need some walls, inner walls and destructible walls. So once again, we need to create some prefabs. I go over and create a prefab folder for that, prefabs. And in the prefabs, I want to drag in all my necessary data. Somehow my cube is gone, so I guess I have to create a new one. But that's not too bad. And the plane is going to be the plane, by the way, over here. So I create a new cube. I do the same basically as I've done before. I lift it by 0.4. I have no idea why I deleted that, but it's okay. And I'm gonna set the scale to 0.8 in all three axes. So it's looking a bit better. And also we can also snap this around or put this somewhere we don't need to, but yeah, that's the point. And I want to make this cube being a wall. We're gonna start with the wall and the wall stuff we are going to create in that very first. So in create level, oh no, first we want to give it, of course, the material, the correct one, this one. So it has this nice texture on it. If you like to, you can also use empty or yeah, white, black, blue, whatever colors, doesn't really matter for you. This is just yeah, for visualization, you know. So, and I rename this one wall. And I now drag this one into my prefab folder. And we are done with that, and I have that already. That's cool. If I don't like that it's so dark, I probably can go and it just makes it even darker, but I can make it even higher, reflectable, whatever. But yeah, it doesn't really matter how you want to make this. Okay, so once this is blue over here, or in 2K 18.3 or 2K 19, that prefabs are going to be handled a bit different. But for now, I'm still at 2K 18.2, so we don't have that yeah, that handling over here at the moment. Doesn't really matter. And I can get rid of that wall. Okay, why I'm gonna change that pretty quick right now. This I duplicate that, or I can just rename this if I like to be a destructible wall, or just a whatever brick wall. This is going to be later on my destructible wall. I'm gonna put another material on it, which is going to be of type bricks. And this brick wall is going to be, or going to land in my prefabs folder over here. So I have now the brick wall here and that wall over there. In create level, we take wall, maybe also inner wall, and the brick wall to drag them here inside over there. So, and the ground plane is going to be this plane. And that's pretty good. So now we need some placeholders to play around with. So they can be anywhere, but I name them or rename them. So outer wall holder. And I make a hashtag in front, so later on I can find this probably easier. Then I duplicate that and rename this one to inner wall holder, like so. And then I need also, what else? What else do we need? A destructible wall holder. Yeah, so I'm gonna duplicate that again and name it destructible wall holder. Delete the stuff here. There we go. So that's what we're gonna do next is we're gonna take outer wall holder and place this over here, inner wall holder over here, destructible wall holder over there, and we're gonna start with a grid size of 5. The grid size of 5 means we're gonna start here at 0, 1, 2, 3, 4. So this is the 5th one, but we are starting at 0 and 5 by 5. This is the smallest level size you should create, because in the center, like every 2, as I explained at the beginning, every 2 ones are going to give you a brick in the center, like from the inner wall. So this is for debugging purposes. This needs to be higher than 5 or equal to 5, and all these numbers always have to be uneven. So 5, 7, 8, and so on. So we keep that 2 by 2 by 2 hopping later on. So a 7 would be like here, and we're gonna have like 2 indents over there. Oh no, 7 would be here, I guess. 1, 2, 3, 4, 5, 2, 5. Yeah, here. So that's what we want to take care of later on in the creation tab, or in the creation phase, I would say. Okay, so what we now want to do is we want to start editor scripting directly, meaning we create at first a new folder, and this is important. We need to name it editor. In editor, everything which is based on editor scripts need to be in the editor folder. It doesn't matter where it is. In the assets folder, it just needs to be there. So, and what we're gonna create now is another script, another C# script. I don't know how I create that, or how I name it. Maybe level editor. So I know it's an editor script probably, I don't know. And this is basically later on taking care of the script you already have done here, the create level one. Let's open this one up in Mono Develop or Visual Studio as you please and like, and start to get the most important things for editor scripting at the very beginning. So whenever it's resizing, there we go. The very first thing we need to make use of is, of course, we need to use the namespace Unity Editor. Otherwise, we don't have access to any of these functions we are going to take care of in a moment. Next one, very important, above the level editor class, we're gonna need to declare this one as a custom editor class. So we say custom editor, open close parentheses, type of, and in here, in this next pair of parentheses, we're gonna want to make sure that we are taking create level as the type of custom editor. So we want to edit this, or actually, make use of everything based on a create level. So any input we have done already, we want to take care of that and make use of it. So we need a connection to this particular script or part. Also, what's more important, I believe, is, which often is going to happen, we want to make sure that we can edit multiple objects, because that's what we want to do. So make sure can edit multiple objects is going to be here as well. Absolutely necessary. So I get rid of start and update because we don't use them. And instead of going with mono behavior, we want to inherit editor, because we want to make use of all the script parts and possibilities inside editor. Okay, so what we want to do is we want to have, or we want to store some like some prefabs which we have created, or we have the connection into create level. We want to store them here because we want to instantiate them on a specific way. We can, I believe, we should be able to take them from the other one, from the create level directly, but I want to avoid any mistakes. This is going to be a private variable, and we are going to take care of that in just a second. So at first we want to take the wall prefab. We are going to start with walls, so I guess we don't do the other ones at the moment. And I also want to have a bool, which is going to be a script active, meaning meanwhile this script is active, we don't want to, or we want to avoid any double stuff. Okay, so now we need a special function, which is also super important for editor scripting. In this particular case, it is a public override void, so of type void, but we override that. What do we want to override in this case is the onInspector GUI. So onInspector GUI. This is super important, and that you also make sure that the O, the I, and the GU and I are going to be all big letters or whatever they are called. So what we want to make sure is, when we have that, let's start here. When we have that, and we go now to the inspector and we go to create level, all of that stuff is going to be gone in just a snap. As you can see, multiple object editing is not supported when we have no idea what's going on over there. So once again, it has nothing to do with that, but with that function, because we are currently overriding the functionality or the input with it on inspector GUI. We are overriding that inspector. What we need to do to visualize that, once again, we need to say draw a default inspector. This one. Open close parentheses and close the line with a semicolon. So whenever you have this line inside, everything which is based on create level will come back after the compiler is done running. Well, should. That's funny that he says multiple object is not working. Okay, there we go. We are back now. I just had to select and deselect it. No, I don't know why. So everything is back to normal. So we are drawing everything based on that. So because we need this input anyways, because later on we probably want to add other different prefabs, like, I don't know, instead of walls, we might want to make use of mushrooms or whatever. And what we now need to do is we need to create a connection to the create level, so we can pick specific items and put them into our wall prefabs to make use of them. So at first, we need to define that, I guess somewhere, yes. So first we make a connection to create level, and we give it a name, maybe just create. And in here, we can say create is equal to, and what we want to do is now we need to typecast create level, and we need to set target here. Target is a special keyword. Keep that in mind. This is important. So now we have a connection to the create level, and we can now take from this target, from create, we can, for example, pick all necessary data, like, for example, this wall prefab. So what we're going to do here is we set wall prefab is equal to create dot, and now we should have access to all walls we want to have here. In this case, I guess the name is wall. So, and then we're gonna close the line with a semicolon. So now we pick the prefab from the create level and put this into our own, like inside this editor script. And now we can make use of it at any time we want. Same for the other ones. We don't cover them yet because it's going to be all the same. So the first function I want to create is that we are able to create the complete border of our game. What do we need to do with that is, at first, we need to create a button based on the GUI. Beforehand, I probably go and, yeah, just do that first. So a GUI layout dot button. So we want to create a button inside our GUI layout, and in open close parentheses and in quotes we give it a name. For example, create border. So with that button I want to achieve that we are able to create a border. And in there, if the script is not active, so we are currently not doing anything else. So if not script active, once again, we are actually protecting that with this bool, so we don't overdo it and make some nasty stuff. In here, we want to create a function, which is of course building the border. So for now, I can probably name that or create that function already. And basically, we can create any function we like inside the level editor script, no matter what. So of any type. For example, we can say here just void build border, open close parentheses, and of course, open curly braces. So now we have access to that whenever we are clicking on this button. I'm going to show you in a sec how it looks. But beforehand, I want to make sure that I begin some kind of layout, which I can take care of, or for example, end some or begin some horizontal layouting inside the editor. So we say editor GUI layout is going to be this one, dot begin horizontal, I guess. Yep, open close parentheses, close the line with a semicolon, and maybe here at the end you want to say this is that we want to end this. Probably we're gonna stick to some more of these layout things later on. Okay, so in here we will just want to say end, meaning whenever we are doing some different stuff like a deleting border, then we want to have a function for that. So we are we put this like into some kind of I would say layout group, something like that. So basically we can do the same. We can, for example, okay, we want to delete the border later on because we are lazy, or I mean, we need to have a delete border functionality later on anyways. We do not want to call build border. Of course, we want to call delete border. So let me just rename it delete border and copy the name and create another void delete border. And whenever you're later on going for the inside and the outside and all the other stuff, you want to make sure that you have for everything a good amount of functions and you just call them from these buttons. Let's have a look pretty quick how they are currently looking. So still we have the create level part in here, but since we are now putting in these buttons into the editor layout, you can see now we also have this layer mask. It hasn't been shown before, I believe, because of the header. And as you can see, now we have a create border here and the delete border. If we wouldn't use the layout group horizontal, they will not be next to each other. They would be one under another. So now these functions do not do anything. So we can click that already, but nothing is going to happen at the moment. That's what we want to create now. So we are now designing everything around the build border functionality based on the input we have done before. And that's what we're gonna, yeah, well, that's what we're gonna do at first. So at first we need to do some debugging, of course, meaning when our grid size is too small and when our when our grid size is too small and it needs to be at least or higher than 5, for example, then we want to make sure that this grid size gets automatically updated. Once again, this grid size is going to be this one. It needs to be at least 5. So that's what we're going to do first. So we make a quick check over here if create. So now we talk to the create one and get some information first. So if grid size x is smaller than 5, I would say 5 should be the correct one. Or this is the OR operator. You probably know him already. With 2 pipes. Or create grid size dot z is smaller than 5. I'm not 1% sure if we are using or make use of 5, but we want to give ourselves first a debug.log warning or something like that. Maybe a warning where we can give ourselves just something like grid size needs to be bigger than 2. So, or than 5. Grid size needs to be bigger or equal. I'm not sure if equal than 5. Once again, we're gonna see all of that. Meanwhile, we are creating that, and of course, we want to return. We don't want to go forward inside the script. We don't want to do all the other stuff, and also we want to make sure that we are checking for even or even uneven numbers because everything needs to be uneven. So what we also want to do is we want to check the grid size, the input, the actual one. So if create dot grid size x modulo 2, probably you know modulo 2, is equal to 0, then, or basically the same, we're going to do for grid size dot z. I'm going to copy this here so I don't need to type it. Or grid size y modulo 2 is equal 0. Then we know, okay, we have uneven numbers. Okay, we need another equal sign here, of course. And then we know, okay, we have even numbers, and even numbers are bad for this particular case, since as I said before, we need uneven numbers to have like a hop in between. So the smallest might be in this case 3 or I guess 5 here. So it's going to be the smallest one. So we are logging or giving out some warnings for us so we don't over or underdo it. Okay, once again, we're gonna say debug.log warning and open close parentheses, we're gonna say grid size needs to be uneven numbers. So we now know that we have to get uneven numbers. How does modulo work? For example, you have an 8 as an input. It takes it and always caps modulo to 2 and round it down until it hits 0 or 1. Whenever it is 0, then of course 8 divided by 2 or minus 2 minus 2 minus 2 minus 2 one day or the other, it's going to return 1 or 2 or 1 or 0, depending on the number 2 here. If we have a 7 like this, we go 7 minus 2 is 5, 5 minus 2 is 3, 3 minus 2 is 1, so it's not equal to that, and we know it's an uneven number. So this is how this modulo stuff, by the way, works. Okay, so at first, before we want to do anything else, we want to make sure that we call delete border, since we want to have some empty borders, basically. So delete border, I call that the function here already. We have nothing inside, but that's fine for the first time, no matter what. Then we want to set our script to be active, so we know now at this point, because we went through all of that debug line stuff, we want to set we are currently doing script is going to be active. And at the very, very end, we want to reset it or already back like script active is equal to false. Like so, and everything in between is going to run. Meanwhile, all of that is going to be done. And when we are done, the script active is going to be false, and we can actually put or click on any other button at this point. Okay, so now we need to loop through the amount of grid sizes or grids we want to create, and of course pass in the correct or needed parameters and check them out. And also we want to instantiate them on that runtime. So first we create a for loop for double tab. I start with I is smaller than, and now we talk to create dot grid size x. As long as it's smaller than that, we're gonna increment I. Then we need a nested for loop for the y or z parameter as well. So we create another for loop in here, which is grid size. I know it's a create, of course. It's inside create dot grid size dot z. So as long as that is smaller than that, and of course we need to, can I rename that to j? We don't want to have I and I because I is not enclosed or closed already. We want to make sure that we have a j inside here, or any other letter or any other variable. So then we are done with that input. And now what we want to do is we want to create a wall. But we only want to do that in another one specific behavior. So if the I is equal to 0, so it's on the bottom left corner, or actually on the left side, or it is on the outer side, like on the grid size maximum amount, like I is equal to create dot grid size x minus 1, then we want to, and only then we want to create a game prefab wall. What is so important about that is we want to create a border, right? And this border is only on the very far left on the x-axis and on the very far right on the x-axis. So, but everything in between, we don't want to have anything in between in this case. And we need to do the same for j in just a second as well. So for the size z. So only when we are in the bottom and only when we are in the top with these numbers like based on grid size x and y or z, only then we want to instantiate game wall prefabs. So what we're going to do is we create a new game object, we call it wall. We might want to, or we want to do that because we want to have access to it and reposition it whenever and however we need to the points where we want to have that. Usually, we're gonna say we want to just instantiate stuff. But the problem is with additive scripting, you are losing the connection to all the prefabs. So whenever you do a change, you are not able to talk to these instances of game objects anymore because they are losing the prefab connection on creation. Instead of that, we're going to make use of an editor kind of a prefab utility, which is only available in editor scripting, I believe. So it's a prefab utility dot instantiate prefab. And what do we want to instantiate? As you can see, it doesn't have much arguments here. We just want to create that wall prefab at the position we are currently at based on the input. Okay. And of course, we need to end the line with a semicolon. So this is also important to make use of whenever you want to instantiate objects and want to keep the connection to the original prefab in your prefabs folder. Now we want to set the position. So we say wall.transform.position is equal to. Now we want to create a new vector 3. And we need to define where we want to place that first. What we want to have is several input parameters. I try to explain them based on the create level input. So first one is going to be the start position. We define like here in vector 3.start. And that's what the first on the x-axis is going to be. So we start at this point. So create.start.x. This is going to be once again the vector. You can also put them wherever you like to. Then we want to increment or include I as a parameter of the position. So when we are at 0 and x is on 0, then everything is going to return 0, of course. But we want to have also the offset inside of this calculation just in case. So we say create a dot offset dot x. Currently we don't have any offset. So later on, when you need to have some offsets, this is going to be land inside this calculation as well. So this is everything for the x-axis. Now we need to put in everything for the y-axis, or in this particular case, everything for the y-axis, which is going to be create.start start.y plus the offset. Because we are not going in the height, we don't have anything about that. Yeah, the height actually, because we only go in the x and enter to the z axis, so we just keep that at 0 basically, based on, once again, the input. So create dot offset dot y. If you want to have anything in height as well later on for creating specific puzzles, you can implement these as well. And the next one is going to be the z-axis. Is going to be rather long, so probably I go one line deeper over here and here as well. So like so. And the last one is going to be the same as the first one, but we're gonna need to use j instead of I. So once again, we start with create.start.y. No, it's z plus j. J is the second for loop over here, only taking care of that. And after that, we say plus, and we put in the offset as well. So create dot offset dot z actually plus, and now once again we put the, oh no, we are done. We don't need to put in anything. So just plus the offset. So this is going to be the end of that line, and we put in a semicolon. So it's a rather long one, but as you can see, rather simple, I hope. Later on we can copy that stuff over here. So once again, we are taking the position of our set it up start position every time I increments and is actually able to be spawned. And then we're gonna make use of the x offset, which is going to be whatever the x offset is, can be, but we are already implementing I in here. So every one unit, we're gonna go and implement that. So currently we have a grid size of 1 by 1 or a 5 by 5, but then we divide that to 5, they're gonna end up with 1, and so on and so forth. So everything on 0 and everything on 5, when we are at I and everything is 5 by 5, is going to be created by that. So the offset can be something like a space in between. It can be negative, can be positive, so we can actually put items closer together or spread them more apart, based on, once again, the 1 by 1 thing over here. Okay, what else do we need to do here? We need to set this game object to its parent. So we say wall.transform.parent. Probably need to, or we can also use set parent, basically doesn't really matter, I guess, is going to be create.wall, what is it? Outer wall holder, there we go. So we want to parent this newly created game object to the outer wall holder, and we are good to go. We can actually play around with that already. Gonna show you. Let the compiler run first. So hopefully he doesn't find any problems. Oh, we forgot to typecast. Of course. So whenever we are instantiating, we need to typecast game object as game object, or you're gonna put this in front into parentheses, up to you again. So we are good to go, hopefully. And when we now go to create level, and this number is 5 by 5, or let's assume it's 4 by 4, and we press on create border, we get a grid size needs to be bigger or equal than 5. So when we now put a 5 by 5 or a 5 by 6, so we actually check for that. It says, okay, grid size needs to be uneven numbers. So the 6 over here is a bad one. But as you also can see, it already started to create these walls only in the bottom and in the top. Or in this particular case, it is on the left and on the right. Like from here, from 0, 0, which is the start, and of every 5 ones. So, and it's going to do this like 6 times in the height, but still it shouldn't work, because since we forgot to return at this point, I believe so, it is created. Also, you can see all these walls are now parent of this outer wall holder. So we now delete them, since we don't have any delete function at the moment. And here I want to make sure that I return, of course. So I don't have any issue later on in creating that borders. Okay, so now we need to do all the same stuff for the J. So for all the other parts, I'm gonna copy this complete block here, leave a bit space. So we now need to change everything over here. So this needs to be J. this needs to be J. This one needs to be the grid size Z minus 1. And what we want to do is we want to instantiate that as a game object. And now we set the transform once again. It's create x plus I plus create offset x. As we done before, we don't touch y. And the y is going to be also in the create offset z value. And at the very end, once again, we are ending the script. Don't forget to save, and let's go back into it and see what's going on. So what we can do is we can clear the console. And when we now press here, nothing will be created because it need to be uneven numbers. So we set this one to be 5 by 5. And we can create the border at start position, which is currently, as you see, slightly offset. Also in the height, because we haven't set any start position offset in that. So, and now we have like walls around our game objects here. I can get rid of them again. And what we now can do here is with these with this create stuff here, I'm gonna get rid of brick wall. We can now position or set wherever we want to have that. So for example, the offset can be something in the height, or we can put it in start. Basically, maybe in offset, we want to lift it like 0.5, and maybe on X, I want to have a negative 0.5 as well. So it's looking more like what we need. So when I create the border now, you can see it automatically lifted by 0.5. Actually, this needs to be 0.4. We are still starting at position 0. So this first wall, wherever the first wall is, let's see, should be that, is slightly offsetted. And we can also bring it a bit down, maybe. Or we're gonna go from the center point from the start position and put this over there. The positions of the cubes are probably based on the child's. So I can reset their positions to 0. So probably that's why these strange numbers happen inside of these walls. So this one is 0.0. When I now say, okay, create level, I press here, I bring this one to be -5, or just keep it for the moment, and put it here. You can see the first wall we are creating are at 0, 0.4 in this case in height, and 0. And they're placed on that. So once again, we can now, for example, go 0.5 left and 0.5 up in the Z-axis or front. Then we're going to start directly on one of these grid fields based on wherever this plane is actually going to be. So I'm going to delete them once again since I don't have the delete function yet. Oh, it doesn't let me. That's funny. Okay, and yeah, once again, I can bring this to 0.5 to the left and 0.5 up. I guess it's up. Or front. Oh, I don't need to press play. Sorry. Stop, create border, and now it has changed by that amount, and basically it fits our plane right now. So pretty decent, I guess. And we can now go forward and fill all the other fields as well, like for example the center ones, as well as bricks we want to destroy, or maybe we don't want to have some specific parts for other things. The most important one now is I want to rearrange, or I want to make sure that I have a function for deleting my walls inside inside the function here. So when I press delete border, I want to make sure that I'm able to do so. So whenever I call that the delete border function, I want to be able that is going to be called, as well as having a button for that so I can do this separately as well. So to destroy borders, we need to have a child count. So we need to know how many childs we have in our outer wall holder. So we say int child count. I just name a child count is equal to, and now I want to count all of the childs of that. So create, it is in create outer wall holder dot transform dot child count. There we go. So now we have a number, and now we loop through them and destroy them. So we create a for loop. We want to loop through that, but we go backwards in this case. So int I is equal to child count -1. And here we say, meanwhile, I is bigger or equal to 0. We want to decrement I, so we delete them from the backside, so backwards, so we don't have any problems. And instead of using just destroy, we're going to use destroy immediate. And then we want to say, what do we want to destroy? It's going to sit in create dot outer wall holder dot transform dot get child. So we want to get the current child. We are looping through. In this case, I. Once again, we go backwards. Otherwise, it will be always the first child. And then we say dot game object. So, and that's how we can delete the border. What does all of that now mean? Is when we create a border, we also call delete border, as we already have written inside. And let's assume we create a border with 5 by 5. Now we decide, oh no, we need maybe a 10 by 10. Doesn't work since grid size needs to be uneven. So we're gonna go with 9 by 9. We create border and it will be automatically expanded to wherever we want this to have. And that's what we need, right? So we need a connection to all of that. I believe we're gonna go and do the plate, the bottom plate also, since I believe you get the idea. Whenever I press delete, by the way, everything will be deleted because we have the connection to the transform. So let's go and talk about that little ground plane inside of that. So I create a new void resize ground plane. We need to do several things in there. It's a lot of mathematic calculations again, as you probably know already. So at first, we want to say we want to resize that over here. Resize at first. What we want to do is first we need to go and put a new vector. So I create a new vector. I name it scalar. He's going to take care of the scale of the ground plane, and it will be automatically calculated by whatever the input is. So we say it's a new vector 3, open close parentheses, and inside at first we want to typecast this one into a float because usually it's an integer, and integer cannot be like 0 numbers. We're gonna take from our level create or create level script, we take the grid size x, we divide that by 10 because we have numbers between 0 and 1 in case of scale. So we at first need to number this one down. So if grid size is 5, we divide this by 10, then we get a 0.5. And then we say comma, the y-axis is gonna stay 1, and then we're gonna have the same for the other one, for the z-axis. So we first typecast this into a float. We're gonna make sure we take the create.grid size z, and we divide this by 10 as well. Whatever the grid size is, we can now take care of that from the scalar. I guess that should be it. Yeah, for at least for how to scale this thing correctly. Now we want to resize that, so we talk to create where our plane is going to be inside. So create.groundplane.transform. And now we take the local scale of that. It's this one, and we set this one equal to be scalar because it's a type of vector. Now what we want to do is we want to position that. Gonna do another note in here. So we want to position the plane according to where it currently is. So create dot ground plane dot transform dot position is equal to, and now we need to create a new vector because again we need to do some mathematic calculations here first. So we're gonna have create dot grid size dot x, our grid size x, then we divide that by 2, so we get half of the size, and that's probably everything. So we take the half of the size of the grid size and position that one onto the x-axis of the ground plane. Then we're gonna say 0 because we don't want to lift it to anywhere. It's going to stay on the ground, and then we're gonna do the same for the y or z-axis in this case. Create dot grid size z, and I believe we're gonna divide that by 2 as well. So we say divide by 2. and close the line with a semicolon. And now we want to access the material or change the material. What is it called? Well, the tiling of that. So we need to access this as well. Material how do we call this? Material material tiling, I would say. Okay, so we set the tiling based on how big the grid size basically is. How can we do that? Once again, we talk to our plane or ground plane. So create dot ground plane. Then we want to have a connection to our mesh renderer component. So get component mesh renderer. Inside over there, we're gonna have a material, but material doesn't really work. So we're gonna make use of shared material dot, then we're going to have a main texture scale, this one. And this one can be set to be equal to a new vector2, since it represents a vector2 only. And now we put in create dot grid size x, comma create dot grid size z, and of course close the line with a semicolon. And that's it. So now the plane, every time we click on that, should be automatically resized and repositioned according to where we start to create our plane for. Whenever the compiler is done running, we try that out. Create a border, but we do not resize that, or actually we didn't call the resizing of the plane. So let's see where we could basically do that. We can create our own function for resizing this, or we can probably call this after we are done with creating the border. So probably we can call resize ground plane after we are done with all of that. I have no idea if that works. Just test it out. Otherwise, we're gonna create an extra button for that. So clear the console. We don't want to get any warnings, and hopefully we don't get any. Okay, and now create a border. And as you can see, since we are also offsetting this one over here, this these cubes gonna get offsetted. Now we don't need to offset them anymore, so we can basically reset these two numbers since we are, oops, wrong again. Since we are, we had that offset beforehand just because we didn't replace the plane. So now I set these to 0, this to 0, and create a new border. And as you can see, it pops back where it came from, as well as our ground plane is automatically resized, as well as the tiling gets automatically set. So whenever you now have to create your own Bomberman levels, like with different materials or different stuff on the outside, you can easily, with just one click, create levels of super big sizes. Let's make 200 by 200. Let's see how long this takes. I have no idea. Oh, it needs to be, of course, an uneven number, so 199 by 199. Create border. And as you can see, our playfield is now 199 by 199 with a huge amount of wall pieces on that, and so on and so forth. And this is why you want to make use of editor scripting, because you can simply just resize things. You don't have to calculate, oh my god, what's the scale now of my texture? What is the tiling factor and all the other things? So this is how it works. So I can go close here. Once again, the smallest should be 5 by 5, so you can put one of these inside the middle. And I guess we're gonna go about the middles again, but we do not do the destructible walls in this piece. So basically, we're gonna have to create another inner wall prefab, or we're gonna make use of the same one. Basically, doesn't really matter as long as you don't have any different ones set it up in the create level. So if you have different inner wall pieces, like when they are green or red or blue, whatever, then of course you want to have a different one. You know what? I'm gonna create one pretty quick. So first I need to duplicate this material, and gonna rename it to maybe green metal or something. Green metal. And I tint this green like so, or whatever. And I'm gonna take one of my prefabs, wall, and I give it something, some different material, in this case the green material, and I rename that to be green wall. And we're gonna take this into our prefabs folder again. So once again, we go to create level and put this instead of the other one into our inner wall prefab. We want to make use of this. We can delete that. And now what we want to do is we want to instantiate that. So first we need a connection to that prefab from our create level script. So inner wall prefab, and there we go. Inner wall prefab. Gonna copy the name, and of course here in wall prefab we want to set inner wall prefab as equal to create dot inner wall, and that like that. So don't forget to save. And now we need a new button for building the inner wall and deleting inner walls. So basically we're gonna do all the stuff here as we did before. We're gonna create or copy that complete part, including the editor GUI layout begin and end horizontal. We want to rename it, create inner walls. And here we want to say delete inner walls. I know we haven't touched layer mask, but at the moment, well, once again, it doesn't really make sense because it is only for destructible walls anyways. Oh, let's see what you have written here. Thanks for tuning in, guys. Is it a question, mister? I guess, yeah, you can use that. Basically, you can use that for 2D tiles as well, as long as the rules are going to be the same. Okay, so now we have resizing the ground plane. We don't need that. We are deleting the border whenever we need to, but what we now need to do is we need to build the inner planes. So, or the inner parts, which are hopping over every 2 steps. So we need to ignore the wall pieces, the outside basically. And also we need to make sure that once again, everything is even and so on and so forth. So that's where we're gonna start right now for building the inner walls. Basically, we create a new function at first, of course, build inner walls. Open close parentheses, of course, we don't need any arguments inside over there. And basically we're going to do the same as we do with these ones. We take all these debugging purposes or debugging lines here and put them into that as well. So once again, grid size needs to be bigger and so on and so forth. So whenever we have or set this one by hand or on its own, then we want to make sure that we are higher than 5. Okay, so also we want to set the script to be active. So script active is equal to true, as we have done before. And at the very end, of course, we want to make sure that we are setting the script active is going to be equal to false, like so. Hi guys, hello man, thanks for tuning in. Okay, and now we want to basically do the same as we have done before, but the distances have to be a bit different. The distance is always a fixed number. So at first, we create that distance. It's going to be once again every 2 times we want to hop over and create one part, one single piece, and only if it is like not a wall piece, and only if it is not an even number. So int dist is going to be equal to 2. We created distance once again as a placeholder, so this number might change later on depending on what you like in place. And what we now need to do is we loop through the distances the whole time and see like based on whatever the grid size is, and always reduce it by 2 as well, by dist in this case, so we are not creating stuff inside the walls as well. So how do we do that? We need to create a for loop at first. We set it as going to be, we start big basically. So int I is going to be equal to 2, or in this particular case, to dist. Since once again, when we want to change stuff like that, and we want to have something like all 3 ones or all every ones, then we can change just that number. That's why I implement this here. Then we're gonna have the x. Oh, so everything is going to be for the x-axis over here. You can keep it and naming I whatever you like. So if I is smaller or equal, create dot grid size x, and then we want to decrement this by distance because we don't once again want to have this inside the borders. And then we increment I. And what do we want to do is at first we create another for loop, which is going for the z-axis. So in this case, we name it to j or z, whatever you like, tab. And in here, we're gonna take if j is smaller or equal than create dot grid size z minus distance or minus dist, and it needs to be smaller or equal to. This is important. And then we're gonna do all our magic, or the editor is going to do that complete work for us. So we say game object, we create a new game object of type wall, or we name it wall. Once again, we do the same. We take the prefab utility dot instantiate prefab, so we don't lose the connection to that. By the way, you have seen that already running since all the walls have been blue. And what we want to do is we take the inner wall prefab, I guess. Yeah, because that's what we want to do is, and we typecast this into a game object, of course. Otherwise, we get the same error as we have done before. Now we want to set this particular little parts of this particular items to one specific position. And since we are currently currently doing all of that once, we want to check everything first in an if statement. Where are we currently? So what we're gonna do in here is at first we want to set I modulo dist. So every time I is the same as distance, we're gonna reset, or we want to check if that is an even or none, or in this case, if I is an even number. So if I, like on the x-axis, modulo dist is equal to 0, then we have an even number, like every 0, every 2, every 4, every 6, and so on. That's where we want to spawn our items at, right? Same for the z or j value in here. Once again, you can rename them if you're confused. So in this case, if j needs to be also modulo distance, so modulo 2 in this case, somehow the parentheses are outside. If that is equal to 0, then we have even numbers, meaning every 2 times we're gonna put this this is a kind of project of me. So currently I'm working on a Bomberman basically, but at the moment it's just part of editor scripting. I want to show you how you can easily create stuff like that. Back to work, of course. We're gonna need to have some open close parentheses. I'm gonna take this line, because it has to be inside. Because we only want to have that or create this if modulo is going to be 0, or in this case, always even number. Something is strange over here. This one here needs to be probably also in the set of parentheses. That's funny. Nope, there's just this one seems to be... wait a second. This one is wrong. We want to have this one here. We want to put this into parentheses. We want to check if this is going to be 0 or in this case, and this is going to be 0. Okay, so this seems to be better, and we don't need a semicolon over here, of course. I don't know where this came from. Okay, so we actually want to create one wall prefab only if that 2 are basically even numbers. So how do we do that? Probably. And only 2. Yeah, that should be correct. Okay, so now we want to set wall dot. This is going to be once again the position of that. We want to reposition them. So wall dot transform the position is going to be equal to. Now we put this onto the correct spots. So in this case, it's going to be create dot start dot x plus I in this case plus create plus the offset plus create dot offset dot x. Now we say comma. I'm gonna go into the next line over here. Since it's once again a bit long, we're gonna take y in consideration as well. So create dot start dot y comma. And of course, in here it needs to be also plus, and we need to put in the offset as well. So create dot offset dot y. And in the very last part over here, next line is going to be again the z value, so create.start.z plus, in this case it's going to be j plus, hey, why does he do that? I just want j. Oh, maybe there are some typos somewhere. Oh, we need to change this one in just a second. This needs to be dist. So int j also needs to start at 2, and then we need to say while j is smaller. Yes, that looks better. So it's that distance. Yes, and we're just gonna implement j. Yes. So once again j plus, and now we're gonna take the offset again. So create dot offset dot z should be the correct one, and here everything is gone or done already, so we can close that. Something is wrong here. I need to find it pretty quick. So of course this is going to be a new vector 3. I don't know how this became deleted. Don't forget to save in between. Sometimes everything can be picky, so just take care. And gonna delete that. And the final step, once again, as you probably remember, is we need to set wall.transform.parent, because we want to parent it to be equal to our inner wall prefab, or inner wall holder, basically. So we say create.innerWallHolder, and that's it. Don't forget to save. Make sure script active is set to be false at the very end over here after the complete for loop is done running. And now we should be able to have every 2 times, if it's not here and not here, we should have a piece in the center. And it's going to be always a green piece in this case. So as you can see, we now have a button for create inner walls and delete inner walls. When I press that, I hope I have something. But we haven't connected these buttons to our functions. Pretty dumb. Bad, I would say. So this is delete border. This is going to be create inner walls. So of course you need to call the function build inner walls over here, like that. And here now we need also a delete inner walls. Maybe we're gonna make that pretty quick. So basically it's the same as we do here. We just go through the complete child count of everything. So delete inner walls, something like that. Open close parentheses, and in curly braces we're gonna put in the child count of the inner wall holder. And what we want to do is inside the inner wall holder again, we want to get the child and destroy it depending on whatever the child count of the inner wall is. So, and of course we want to call delete inner walls, copy that name, can close this, can close that, and in here we want to destroy inner walls or delete inner walls, and there we go. So now when the compiler is done running, we should be able to create inner walls. Boop. And as you can see, now one green wall is getting created because we only have one piece which we can basically take into it. So this is a not destructible wall later on. So we are actually done with the complete work in creating a complete level. In this case, once again, we don't cover the brick walls because it's just hopping all over and filling them randomly. Probably I provide this in another tutorial or in another one because we are streaming already over 1 hour and 10 minutes. And so I will conclude this pretty quick over here. So in create level, once again, we type in something like a 9 and the 9. And we can first create a new border for that. And we can create inner walls. As you can see, they always hop over. And you can also see these are 9 in total. So everything works completely correct over here, it seems. And now you can just place your characters inside. You can create any size you like and please. They can be thin, they can be big, they can be whatever. Once again, they can be different like that. Of course, we need to delete them in a side over our function as well. Delete inner walls, copy, and we go to build inner walls. And before we do anything, we want to make sure that we delete the inner walls here as well inside build inner walls after we are not returning false over here. So we can simplify all of that. And if you want to say, okay, I want to create something random, you can randomize these numbers and make sure they're all even, as well as putting one big button like complete any random kind of level, so you don't have to put in anything at this point. I don't cover this one yet, so just once again create, and we can click like 2 buttons and everything is good to go. And if you're unhappy with everything, we can delete them and only the plane is going to be left. And yeah, that's everything for this rather huge run already. I hope you enjoyed this one, and if you need help for the future on your own games or whatever you please like, or maybe you need some 3D models or whatever, feel free to go to octomangames.com. The link is in the description below, and there you can go and send me a message like over the contact form, and we can probably build on something. Of course, for a little fee, I gonna provide my service right now. So whenever you have trouble with your own games or you need help with whatever it is, feel free to contact me over my website, octomangames.com. Thanks a lot for watching. I hope you enjoyed this one, and I hope to see you into one or the other tutorial in the future. Thanks a lot for tuning in once again, and bye bye.